Given information is a wire of uniform cross section and resistance 4 ohm is bent in the shape of a square ABCD. Point A is connected to a point P on DC by a wire AP of resistance 1 ohm. When the potential difference is applied between A and C, the points B and P are seen to be at the same potential. What is the resistance of the part DP? So our question is, this is the shape of the circuit of total resistance 4 ohm. It means resistance of each segment will be 1 ohm, 1 ohm, 1 ohm and 1 ohm. This point is A, this point is B, this point is D, this point is C. Now a wire of resistance 1 ohm is connected from A to P. Resistance of this wire is 1 ohm. Let us suppose resistance of DP wire is R. Then resistance of remaining PC wire will be 1 minus R, because resistance of DC wire is 1 ohm, and if the resistance of the segment DP is R, then resistance of remaining segment PC will be 1 minus R. In this given question, when a potential difference is applied between A and C, the point B and the point P are seen to be the same potential. So first of all, we will convert this circuit diagram into a simple circuit. Let us suppose this point is A, this point is B, this point is P, and this point is C. Resistance between point A and B is 1 ohm, so resistance of this segment will be 1 ohm. Resistance between segment B and C will be 1 ohm, so resistance between point B and C is 1 ohm. Now the resistance between P and C is, we know that 1 minus R. So resistance of it will be 1 minus R. And resistance between A and P will be equal to, resistance of DP is R, and 1 ohm is in series combination with this segment, so equivalent resistance of this both resistor is 1 plus R, and this 1 plus R is parallel with 1 ohm resistor, so its equivalent will be R equivalent will be, we know that in parallel combination R equivalent will be R1 R2 divided by R1 plus R2. It means R equivalent will be equal to 1 plus R, R1, and R2 is R divided by 1 plus R, R1 plus R2 is 1. So it is R plus 1 divided by 2 plus R. So R equivalent is equal to R plus 1 divided by 2 plus R. So resistance of this resistance will be R plus 1 divided by R plus 2. And in this question given information is, when potential difference is applied between A and C, potential difference is applied between A and C, the point B and P are seen to be at the same potential. So point B and point P are in same potential. It means it is in balanced Wheatstone bridge condition. If potential of B point and P point is same, it means ratio of R1 and R2, ratio of R1 and R2 is equal to R3 and R4, because potential of point B and point P are same. So value of R1 is 1, value of R2 is R1, R plus 1 divided by R plus 2, it will be equal to R3, value of R3 is 1 and value of R4 is 1 minus R. So we can write here R plus 2 divided by R plus 1 will be equal to 1 divided by 1 minus R. So we will cross multiply this, so we can write R plus 2 into 1 minus R will be equal to R plus 1. So if we will multiply, then it will be R minus R square plus 2 minus 2R will be equal to R plus 1. So if we will take all the terms in RHS, then it will be 0 is equal to R square plus R plus 2R minus R plus 1 minus 2. So 0 will be equal to R square plus 3R minus R. So it will be 2R plus minus 1. So now we will calculate. So we can write here R square. So we can use quadratic equation formula. Then value of R will be equal to minus 2 plus minus root under B square. It means 2 square minus 4A into C divided by 2A. So value of R will be equal to minus 2 plus 4 plus 4 by 2. Minus sign will not be taken because resistance of any resistor cannot be negative. So R will be equal to minus 1 plus root 8. It means 2 root 2. So R will be equal to, this will be 2 divided by 2. So R will be equal to minus 1 plus root 2. So R will be equal to 1.41 minus 1. It means 0.41 ohm. So in this question we have to find what resistance of dP, which is equal to R. So resistance of dP is 1 ohm. Resistance of dP is 0.4 ohm. This is the answer.